So I have du dt is equal to 5. So when we come back after the break, we're going to find v, and we're going to have du, and we're going to apply this formula. And we're going to end up with something here that is in the tables. Okay. So we'll come back around 25 minutes. So where were we? We had an antiderivative to do. As I said, you should kind of, you will get it's on the exam paper, you'll need integration by parts. Otherwise, you look at it, it's multiplied together, you can't do it directly. There's no manipulation. There's no, a W substitution won't work. You could try one, it won't work. So you need to try parts. You write down this here, which is on the exam paper, and this thing here is what you have. You pick the u by the ate, so you say there's no logs here, there's no inverse trig algebraic, yes. Now that is an algebraic, minus 3t, but it's not multiplying, so this is your u, and everything else is your dv. So you pick the u, you pick the dv. Now we want to talk about why is v equal to this thing. Right. Now I can give a kind of a rough answer, which is actually kind of good, and then I'll give a slightly different answer. So dv. Now we didn't go back. We didn't really. I didn't do any review of integration. I just did antidifferentiation. But what integration actually is adding up loads of small things. We might see this maybe towards 10 o'clock. And this symbol here, what does it look like? S. And that S, did you say F?
Yeah.
S, sorry. It's like an S standing for sum. So this means add up. And this dv is a little bit of v. And in this explanation, you add up all the little bits of v, you get v. Okay. Another way of explaining it is like this. It looks like there's nothing to antidifferentiate. How many dv's have you got? One. So it's like 1 dv. And what do you have to differentiate with respect to v to get 1? V. So whatever way you want to think about it, antiderivative dv gives you v. So if you've got a dv and you want to get v, you basically integrate this. Okay. Right. Now the next thing we said is, okay, we've written this thing. Okay, so we've got u. We want to get v. You get dv from dv by integrating it. And so we've got a little antiderivative here. So what we have to do is go to the tables. Now, if you've room down here, I can write it the appropriate tables thing. So what's in the tables is e to the ax. You look in the tables, that's in there is 1 over a e to the ax. So this thing can be done in the tables. Now the role of x is being played by t. What is a here?
Is 3.
Minus 3. So it's like e to the minus 3 x dx. It's like that, except it's t, and the a is the minus 3. So it'll be 1 over minus 3. E to the ax, e to the minus 3t. So we have u, we have v, and now we also have to get du. And how you get that is you differentiate u, and we differentiated, we got 5. So to get the du, just multiply both sides by dt. So du is equal to 5 dt. So we're going to put everything back together using this thing here. And I'm going to write udv actually. So udv, which really means this thing, is equal to. What is our u?
5t.
5t. 5t. What is our v?
Is minus 1/3.
Yeah,
Yeah,
minus a
minus
third. Yeah, it is minus 1/3. So that 1 over minus 3 is minus a third. I'm going to just write it as it is just for now. Minus antiderivative of v, well this is still v. Times du, what's du?
T, 5 dt.
5 dt. So integration by parts is doing all that. Now this isn't finished. We can tidy it up a little bit. So the first thing is the first term there, the 5t, you can imagine it being plus. What about the sign of the second thing? It's minus. So you got a plus by a minus, which is minus. So that minus, that's with the minus 3 there. Essentially you can take that out as a constant if you want. So this will be, and that's actually, write this bit quite small. It's going to be a bit short on space. So the minus, you got plus by minus, that's a minus. Now you got 5 divided by 3, or 5 by a third, 5 thirds, whatever way you want to think of it. Yeah, we're going to be tight on space here, sorry. Times e to the minus 3t, oh, and the t. Sorry, so minus 5 thirds t e to minus 3t. Now what we're going to do with the other thing is we're going to fix the constants. So what are the constants multiplying in this? Say again, 5 thirds. And this is minus, and this is minus. So minus minus gives you plus, and fix the 5 thirds. So minus minus is plus, so fix the constant 5 thirds. And what we're left with is antiderivative e to the minus 3t dt. Now we won't be able to tidy this up at the end, but the next line is good for full marks. I'd like to tidy the next line up a little bit, but we won't get there. So rewrite this, the first bit is just there. Minus 5 thirds times t times e to the minus 3t. Fix the 5 thirds. So we're confronted now with another antiderivative. So the first thing we do is we go to the tables. Is e to the minus 3t in the tables?
Yeah.
Yes. It's one of these yolks. So 5 thirds times 1 over minus 3 e to the minus 3t. And although I'd like to multiply that out, it's nearly good for full marks. What do I need to do for full marks?
Tidy up the 5 times.
No, that's okay. So you could have minus 5/9 there. I'm quite happy. Plus c. So this is looking for all the things. It's not an integral. The answer isn't a number. It's looking for all the things that you anti-differentiate to end up with that. If you differentiate this, you'll end up with this, but it could be like plus 2. What's the derivative of plus 2? 0. So plus 3 or minus 6.2, you need a plus c here. So you could tidy up that term, but we don't have space for it.
You see, sorry JP, you see the way you have the sum of u by dv, you know the way you have that second part of the line there, you have it as a minus, so you have down, yeah, that line, just, you have a minus before that. What, there, how did that become a minus there? Where's that from? Ah, I didn't see that, okay, cool.
Okay. We'll do any more questions here? We'll be doing 5 examples here. Right, another one. X log x. So we'll go through our strategy first. So tables. Now x is in the tables. Log x, actually I don't think is in the tables. Actually, no. And that'll bear a question, why is log x in the tables? We'll talk about that a little bit later. So so actually log x in the table, so it's not in the tables. Manipulation, there's literally nothing you can do to rewrite that. Substitution, you're never going to do w equal to x, because all you'd end up with is w log w dw, which is exactly the same thing. So the only reasonable substitution is w is log of x, and you end up with this, which is no better. So you have to do integration by parts. So again, I recommend you write down the formula u dv equals u by v minus v du. So what you have is the u dv. And you will rewrite it, and if you do it properly, this is basically something, so you actually know the parts, so the parts is kind of, I think here here's a bit of it, and here's the other bit here. I don't know. Yeah, here's basically you antidifferentiate the V. Yeah, it doesn't matter, it's called integration by parts. Right. So the first thing you have to do is pick your U. So you go through the ate. L for logs. Is there any log in here?
Yeah.
Yeah, log of x. So the U doesn't have to be the first thing. The U is the first thing on the ate, so the U is log of x. What's left over? X dx. So everything left over is the dv x dx. Right. So we're going to do some business down the side here. So again, I'll call it udv. Equals u. Have I got u?
Yeah, log of x.
Log of x. I'll just write that down. Have I got v?
X dx is v.
No, I don't have v. I don't have v. How do I get v from dv?
Differentiates.
Nope.
Integrate, sorry.
Integrate. So v is the integral of dv, which is the integral or antiderivative x dx. Confronted with an antiderivative, first we go to the tables. Is x in the tables?
Yes.
Yes. How is it in the tables?
X plus 1, x power 1.
It's x to the power of 1. So what is it?
It's 2x power 2.
So add 1 to the power, divide by the new power. So the v is x squared over 2. I can put that in here. So it's log of x times x squared over 2. So that's uv minus antiderivative. V is still x squared over 2. Times du. How do I get du?
Differentiate log of x.
Yeah, differentiate u. So differentiate u. So I get du dx equal to, what is the derivative of log of x?
1 over x.
1 over x. Now if I want to get dx on its own, du on its own, how do I get rid of, now this thing, what we do is actually nonsense, but it gives you the right answer. You can show that it always does, so it's kind of allowable nonsense. How do you get rid of that dx? Multiply. So multiply both sides by dx, you get du is equal to 1 over x dx, and put in that du 1 over x dx.
Would you have to do x minus 1 dx? X power minus 1 dx.
You can.
It won't really help.
It's not wrong. No, it will help. You can do it that way. I don't think you have to, but you can. You can ask, yeah.
Where's the x and the logs?
So the x on its own isn't there, but x is x to the 1. And what's in the log book?
E to the
No, x to the n. So you should see x to the n. So it's add 1 to the power, divide by the. Can you see that in the?
yeah.
Yeah. Okay. Right. So the first bit is fine. Now, maybe I'm going to write these the other way around, and I'll just ask, why the hell did I do that? Why did I write it the other way around? You don't have to.
Sunita?
Hmm?
Sunita? No.
I think it is, but I don't know why it is. There's a good reason to do that.
So you don't like subtract the x squared.
Yeah, so that's times. So yeah, so you don't multiply them together. It's log of x by x squared over 2. It's not log of that. So there's a possible ambiguity there. There's no ambiguity here. Right. So the next, and we have another antiderivative. Now I can ask you something like, just independently, the constant is no problem here. What is this constant multiplying? X isn't a constant. 2x squared isn't a constant. It's not actually 2. It's not multiplied by 2. It's a half. It's a half. Yeah. So I can fix that as a constant. And I'm left with, if you just forget about the 2, which is, well, the half, that's sorted. So I'll ask you 2 questions. Is x squared in the tables?
Yes.
Is 1 over x in the tables?
Yes.
Can I use the tables?
Yes.
No. Why not?
It's
Because they're
multiplication.
multiplied together. So can I use the tables? So the next thing is manipulation. Can I rewrite x squared? Can I rewrite that?
Yeah. X squared over x
Big
dx.
over 2x.
What's x squared over x?
1.
Oh, he has it.
Squared over 2.
X squared over x is equal to? No.
Okay, one x.
X, yeah.
Well, you're right. Squared over.
So the 2 explanations. X squared divided by x. So this is x by x divided by x. That's x divided by x.
0. 1.
1 by x is x. Alternatively, you can do x squared over x. What's this as a power of x? 1. What happens with division of like powers? Subtract. X to the 1 equal to x. Well, we're going to need x to the 1 anyway. So that thing, yeah, so that's a manipulation. So the 2 is sorted. It's a half. X squared divided by x is x. And then as we saw over there, that is in the tables because it's x to the 1. And so we have x squared over 2 times log of x. Fix the minus a half. And what is the antiderivative of x to the 1?
X squared over 2.
X squared over 2. So x to the 1 plus 1, which is x to the 2 over 2. And we have space to tidy this up. Now if you have a plus c, I'm giving you the marks, but it's a bit nicer, I think, to do this. So x squared over 2 times log of x. And how do you multiply fractions together?
So which is going to top and then the bottom.
Top, bottom, bottom. 1 by x squared is what?
X squared.
2 by 2 is 4. And plus c.
Where did you get the half?
And this one. Okay, so so there's kind of a quick way and a slightly longer way. So the long way is something like this. We kind of saw this earlier. Say if you've 2 over 3, that's 2 by 1 over 3. So what I have here is, say, x squared divided by 2 is the same as x squared divided by 2 is the same as multiplied by a half. There's various ways of explaining this. I kind of had it earlier on. Yeah, that's pretty much it. So multiplying by a half is the same as dividing by 2. If you have €100 and you're sharing it between 2, dividing it by 2, you get half. And then with antidifferentiating and differentiating, it's linear, which means you can fix constants. So this says antidifferentiate. So if you want to antidifferentiate a constant times something, you can fix the constant. That's why the half comes out. And then you're left with the x squared by 1 over x, which we said was x. that's how that happens. 2/3 is 2/3. X squared over 2 is x squared, so exactly the same as x squared divided by 2 is equal to x squared by 1 over 2. I can't do any better. The only other way I would say is faster is divided by 2 is the same as a half. Yeah, I can't